my calculator to take our first vector, vector f, and find its component forms. So I'm going from polar to rectangular. We can go ahead and use our settings on our calculator. Make sure you are in degree mode. And that part's going to tell me my x coordinate. I need to do it again to find my y coordinate, also with the same settings, 30 and 125 degrees. So I'm finding my two component forms of this, my two component parts. X is negative 17.21-ish, negative 17.21. And my y component from my calculator tells me I'm looking at about 24.57. I have an x and a y component. I need to do the same thing for my second vector. I need to find an x and a y component so I can then add the two of these items together. Dear calculator, I need an x and a y for 90, negative 10 degrees. Make sure you're putting that negative in there. I need a y coordinate as well, so I need to type the same thing in twice, asking my calculator for two different items. It tells me my x component, 88.63, my y component, negative 15.63. Now that I have these two vectors that correspond with my information from number 4 in the book, I can add these two together to find their resultant vector. So from here, I'm going to add my x's together. This one's negative. I'm finding 71.42 for my x component of my resultant vector. I also need to add together my y components. My resultant vector has these coordinates. But since we need to end in the same form in which we begin, we are in component form. I have an x and a y. I need to convert this back to a vector form, a magnitude, and a direction. So it tells my formulas tell me that my magnitude is the square root of x squared plus y squared. You know what? I'm going to ask my calculator again. Dear calculator, this time I want to go from component form into polar. I'm going to use numbers 5 and 6 in my angle menu. I have a rectangular form. It's 71.42, comma, 8.94. When I have a magnitude, I also need a direction, 71.42, comma, 8.94. So I now have a magnitude and a direction right from my calculator. And what I'm finding is that magnitude is 71.9, oh my goodness, so close to 72, and 7.13 degrees. If I use these two vectors that I have in the book, anytime I go into polar form on my calculator, I need to double check that it did everything exactly correctly and looking pretty good. So I need to make sure that this polar form that I've come up with matches the polar form of what I should be seeing from my two vectors that I have here. So I'm going to try to kind of sketch these. I have a ordered coordinate grid. The first vector was going up in this direction. So I draw something about the same in the same direction. From the ending point of that vector, I'm going to draw something that is as close to my second vector as possible. I think it's kind of like that. I feel like I should be somewhere in quadrant 1. Here's my resultant vector, right here, from my original starting point at the origin to my ending point right here. And so let's see if that matches what I'm thinking it might match. I start my pen in its normal position. I have a positive 7.13 degrees. That's going to put me just barely up here. And I am moving towards the tip of my pen to get to this ending point, 71.98. So that seems to match out pretty nicely. So what we have is a resulting magnitude of about 72 pounds of force applied at an angle of about 7.13 degrees. And when I see this, it looks like it's north of east. We need to use these references as we go through it. There's our question number 4 from our homework. Let's go to our second one. I gotta look up what our second question was. I think it was number 6. Oh, number 7. All right. So let's go ahead and check what our second one is showing us. Question number 7. Are there any leftover questions from number 4 before we go look at number 7? All right. Number 7, I'm going to kind of get you set up and then I'll set you free. Number 7 tells us something about a ship that is sailing for a little bit of time. So I have a ship that's sailing for 10 hours at a speed of 14 knots, that's nautical miles per hour, at a heading of 72 degrees north of east. Let's draw our nice little boat. 72 degrees north of east. And it's traveling for 10 hours at 14 knots per hour. How many total nautical miles does it go if it's going 14 knots per hour for 10 hours? 140. So this one's magnitude is 140. My first vector is at 140, 72 degrees. At that point, it says that this boat then turns to a heading of 57 degrees north. So I'm going to kind of think, all right, back to a horizontal. 57 degrees north of due east. It kind of turns in this direction, 57 degrees. And travels for 2 hours at 11 knots per hour. How many total knots, how many total nautical miles is it going? 22. It ultimately asks me, hey, now that this boat has gone up here and is now sitting up here and kind of hanging out, I want to know how far that boat went east and how far that boat went north in total. So I'm going to have my resultant vector heading up this way. And I need to break it into its 2 component forms. We know components as x and y, but when we start putting directions behind it with a compass, we're looking at how many miles east it's going and how many miles north. Thanks, Aaron. So we'll break it up into those 2 parts. We have to follow our same process that we were using before, so we do need to get it into its 2 component forms first of all. And then once we have it into its 2 component forms, we'll add them together. This one looks like we still want to keep it in components, so we'll keep it that way. Again, I'm going to turn to my calculator to help me out and take care of most of the heavy lifting I have. Again, I'm checking I'm in degree mode, going to my second apps button, second apps, which is the angle menu. I have polar, I need x and y. My first vector has an x component of 43.26 and a y component of 133.15. We need to again calculate the same thing for our second vector. My second vector has an x component of 11.98, a y component of 18.45. I need to add these two components together. So my resultant vector has an x component, or an easterly component, since we're looking at that. It has gone 55.24 nautical miles east. And it asks for that northerly component, which is looking a lot like our y component of it here, at 151.6 nautical miles north. In this way, I can find exactly where that boat is compared to its starting point.